Hello, everyone. Our first quiz. And so perhaps it's because it's our first quiz, let me repeat a little bit of things that I have said elsewhere already about these quizzes and so on. Well, first of all, this is a review of the quiz, but don't think of this as the only review of the quiz. The homeworks, especially the homework solutions video, they are always very much focused always towards what we're going to do on the quiz. And also, of course, the lectures themselves and other homework problems. So don't just use this as your single preparation. That might not be enough. I'm not saying that it's not always going to be exactly what I say in the review, but it is going to be always something you definitely should look at. That's the first thing. The second thing I will also say about quizzes themselves. There is, you know, you have signed this code of honor, the pledge that you will not use any foreign elements, no online programs, no other resources except for your own notes, your calculator, and the textbook and the videos. You can always, during the quiz, you can always go and look at the video review, so that's fine. But nothing else, nothing outside that, and of course, for sure, not anybody else. You cannot ask questions to anybody, not people from your own class, but also other people that you might be tempted to talk to. So be honest with this. It's important to be honest. And one way for me to actually see that you do this, that you don't use, for instance, Wolfram Alpha to solve this, because Wolfram Alpha can solve these things. So if I ask you an equation like that and you just solve it with Wolfram Alpha, what recourse do I have to prevent you from doing that? How can I? What point is there then, right? So that's where I will really subtract a lot of points if you don't show the steps. So any result, any step from one to another line that is unsubstantiated or there is a break in the argument, I will subtract points for that, because I just will assume there's no way that you can just get from one line to the next line by mere guessing or by manipulation. So there's something missing. Now, what people do is they solve this problem sometimes on a scrap sheet and then they copy it over and then say, oh, I put this calculation on my scrap sheet, but I didn't copy it. Do copy it. You have the whole day, and the copying of this little part is not going to take that much time, and you would lose points if you don't show all the steps. Now, what do I mean with all the steps? It's what I show in this video and in all the homeworks, and whenever I do this, I show all the steps. That's what I mean, okay? Don't exaggerate with little steps here and there. You can go a little bit fast, but no jumping and nothing, no formulas, all of the solutions that come out of the blue without any justification. All that said, let's go to this preparation for the first quiz on linear first order equations. I'm going to only do one example. So with the equation that you see here, so I remind you, this is the general equation. Now it doesn't look like that because of the x in front of it, but we know what to do. We just divide out by x. So the equation that we really want to look at is this equation, right? We divide by x, so also of course the right hand side, and that's why we get x squared ln x. Okay, so this is really the equation that we will work with. And now there are several steps, and that's what I mean. All these steps you have to show. First of all, we have to talk about the complementary homogeneous equation. What is that? Well, that is the part where we put f equal to 0, so the left-hand side, the terms that involve y. And we put this equal to 0. So this we have to solve. And the technique that we do is basically also the technique that we see in the later sections, separation of variables, right? We bring this to the other side, and then we bring it, split off the y variables and the x variables. Now, for instance, when it comes, if you ask me how much detail from here to there, that is considered as that I'm not going to say, oh, you skipped a step. No, that's not really skipping a step, okay? I find it easier to write these things with the dy's, with these infinitesimals. So remember that what you do there is you say that y prime is actually dy dx, and then you pretend as if it is a quotient and bring the dx to the other side. That way it's clear that what we're going to do is integration, and to the left is integration with respect to y, and the right is integration with respect to x. Now they're both the same thing, that is ln y equals ln of x plus a constant. What we're looking in a complementary homogeneous equation, so what we're looking for is this general homogeneous solution. Okay, this little subscript h reminds me it's homogeneous. So ln x plus a constant, let's call this constant d because I want to later use c for something else. This is implicit. We need an explicit equation if we can. We won't always be able to do that, but in this case we can. So we do exponentiate. So this would be e to the ln y, that is y, and then e to the ln x plus d. And that's of course a common trick, is to split this as a product and then say, okay, this e to d is a constant that I'm just now calling c, and this e ln x of course cancels and it's x. So what I have is that my homogeneous solution, the general homogeneous solution is yh equals cx. Okay, step 2. I'm going to now find a particular solution. So this P stands for particular. I do it slightly different than in the book. And perhaps, I don't know, for some people find it a bit confusing that they like to go to the textbook. Be sure both methods are correct and give the same answer and come down to the same thing. I put it together a little bit differently. So I call this particular solution, and we do this by using, instead of this c, which is a constant, we want to make this now into a variable, a variation, a parameter as we call. So this means that this is depends on x. And then let me perhaps write it more first in formulaic form. So this is what we do in general. That's the general formula. We use the homogeneous solution, but any one. Just any non-zero one is fine. So we can choose whatever c we want in this step. So in this step we take c. So we take c equal to 1 here. So this means, let me put it here. Y is u times x. That is where the c is 1. The u is the new variable that I introduce. And now I drop in this p and h because I'm doing the calculations. In the calculations I just write y and x. Okay. So this is what kind of this type of solution I'm looking for, and I'm trying to find what u is. And of course, the first thing I have to do is take the derivatives. Let's take the derivative first, copy the second, plus copy the first, take the derivative of the second, which is 1. Okay, that is y prime. And then you plug that into the what equation? Well, now of course into the actual equation here. Okay, so let's plug that in. Y prime is u prime x plus u minus 1 over x divided by u, minus 1 over x divided by, minus 1 over x times y, sorry, I don't know what I said, ux, equals x squared equals ln x, yeah, is x squared ln x. Great. These x's cancel here, of course, and we know what has to happen, and that's why we know that we make a mistake if this doesn't happen, is we have to get rid of this u here, because we will find something that is really u prime equals a function of x. Of course, to do that, we have to divide both sides here by x, and so eventually we get u prime equals x ln x. Okay, and that means, therefore, that u is the antiderivative of x ln x. Now, that's why I chose a little bit particular type of integral here, that you practice everything from Calc 2. I just want to make clear here that everything from Calc 2 is still valid and is necessary. So I hope you did your Calc 2 very recently, hopefully last semester, and then you have no hard time to review all these different methods. What method is this? So I'm going to do this on the side. The reason that I'm doing the side is because I'm going to have to use the integration by parts method, and that also involves a u, but that's not this u. So when you do something on the side, then you can reuse variables that you have used before, but it's just a side calculation. Okay, so we have to do this, x ln x dx, and we're going to do integration by part, which is also very often called I-late. That's just an acronym for L stands for log, Alg stands for algebraic, which is what we have here. So the log is the ln x, The algebraic is the x. And what is the purpose of this? Well, we know what is higher is u and what is lower is dv. So we have to do u equals ln x, and dv is equal to whatever is left, x dx. Don't forget the dx. So that's the first part. Once we made this choice, we have to find the corresponding derivative, du, which is 1 over x dx, and also the antiderivative v equals x squared over 2. Why? Because in the formula, this is uv minus integral v du. So we plug everything in. U times v, that is x squared over 2 ln x, minus v, that is x squared over 2. Du is 1 over x dx. Now, typical of the integration by parts is that it always is a new integral. It's never finished in one step. So we have to deal with this integral. Now, if this is a bit long time ago that you do calculus, you think, oh, product rule, I'm just going to take the antiderivative of the first factor and the second factor, and I'm done. No, that's not how it works. There's no product rule. So what do you have to do here? It's simple, but it is very important. You have to simplify. So we have to simplify here. And in particular, this means one of the x's goes out. So what we have left with, let me write it up here, x squared over 2 ln x minus a half, I'm bringing the half out. And then I have, what is left was an x dx. Now that is a very simple integral. That is just x squared over 2. Okay? Now, plus c in general, but we are looking for a particular, the word particular in particular means just one. So I don't need the plus c here. So this is the one that I'm going to go with. And sometimes people like to simplify this a little bit and write the x squared over 2 out. Factor it out and get an ln x minus a half. Be careful, there's a half here and another 2 there, right? But that's not necessary. That's another question. One thing I do not care about, and you don't have to work for, is to do the simplifications of your answers. Of course, at some point in the intermediate calculations, you might need to do simplifications, but at the end, it's not necessary. Okay? Definitely not on the quiz. So be careful now. We have to put things together, so let me call that step 3. First of all, what is the particular solution? Now we should perhaps that's still step 2, but let me put it here in step 2. Step 3, remember it is the u that we find times x, times our homogeneous solution. So this is my u, but I have to times it with x, so x cubed over 2 ln x minus a half. So I repeat, this comes from ux. Right? And the extra x is this x, leads to this x cube. So now that's one solution, that is true, but since we have an initial value problem here, initial condition problem, this is probably not the right solution. You can try to plug in 1 here and you see it doesn't come out to be, if you plug in 1, what you get? Well, this would be 0, this would be 1/2, and this would be minus half. So you get minus 1/4. That is not what it should be. So why is that? Because this is just one solution. So how does the general solution look like? So the general solution, and this is where I do it differently than the book. The book has a formula. I like to reduce the number of formulas as much as possible, because these are just calculations anyway. Why would you write formulas? So what I do is, okay, I say the general solution is you take the particular solution and you add there any homogeneous solution. In other words, the one that we have found here. So let me now circle these things. This is the general homogeneous solution. This is my particular solution, and I put them together. So I get, so y is x cubed over 2 ln x minus a half plus cx, right? That's this guy here. Okay. And that's so step 4, the initial condition. Initial condition. That is, if x is 1, then y is 3, if I remember well. Yep, if x is 1, then y is 3. So you plug this in here. So y is 3, and then x is 1, so I get a half here. The ln of 1, okay, I'll write it, but that's a 0, right? Minus a half, plus c times 1. Okay, so what we have, we said this is 0, and so we are left with 3 is equal to minus 1/4 plus c. So bring the 1/4 to the other side. That means c is equal to 3 plus 1/4, which is 13/4. Okay, so the solution, it's always good it's a simple step, but write down the solution, right? And box it or do something that I see, oh, that's where you end, where your calculation ends. So let's write it up. Y equals x cubed over 2 ln x minus a half plus 13 over 4x. Okay, that's the solution. Now, there is another step. I won't call it a step, but I'll write it between parentheses. Again, it's not something you need to do, but since you have a whole day and you want to get the maximum points, right? You don't want to have mistakes. You can say, okay, I'm kind of a bit bored here anyway, so let me just check it. So you can always verify. So check by just plugging into the original equation. What we have to do, it's not so hard in this case. As we progress through this course, we will get more and more difficult, more complicated differential equations, which have much more complicated solutions, and then it can be really cumbersome to actually check the answer. But here it's not so bad, and it's a good practice to practice your product / quotient rule / chain rule, whatever it is that we learned in Calc 1. So y prime is, okay, so this first part is a product, so I have to do the derivative of the first, that is 3x squared over 2, copy the second factor, plus copy the first factor, and now take derivative of ln x, which is 1 over x, and derivative of minus half is 0, so there's nothing there, plus, and then the derivative of this last term is 13 over 4. Okay, so that's y prime. Okay, be careful. Now, what do we have to do? This is not what we have to do. There's more, right? So we have to put this in the original equation. Let me copy this original equation. Okay, that's this way, and then this is my scissors. For some reason, my scissors look like. Okay, and I can copy it here. Put it right down here, just so that I don't make any silly copy mistakes. So this is the equation. That's why this is where I'm going to plug this in. Oops, still in there. So I'm going to plug this in here. So this, let's now verify that both sides are equal. If I plug it in there, I get 3x squared over 2 ln x. I'm going to expand this already. Minus 3x squared over 4. And I also multiply this. That is plus x squared over 2. The x is cancelled here. Plus 13 over 4. That is y prime. Then I have also y over x. Oh, what is y over x? This is y, right? So divide everything by x here. So minus, I would get x squared over 2 ln x minus a half plus 13 over 4. Remember, what I had to divide by x here, right? I have to divide by x, and that is why here is an x squared, and here the x is gone. That's what this is there. Okay, and that should come out to be this. Okay, now let's see. Hopefully that's the case. 3x squared over 2 ln x minus 3x squared over 4 plus, let's put this on common denominator, 2x squared over 4 plus 13 over 4 minus, and then we have here an x squared over 2 ln x, and then minus is a plus x squared over 4, and then a minus 13 over 4. Don't forget that this minus distributes over everything. Okay, let's see now miracles of cancellation. Oops, minus 34 plus 34, I have 2x squared 4 plus an x squared 4, that's 3x squared 4 minus 3x squared 4. So these three terms together cancel, and then these two are like terms, and so they are also in common denominator. This is 3 halves minus a half, so this is 3 minus 1, so this is exactly 2x squared ln x over 2, which is exactly x squared ln x, and this is exactly what it needs to be. Again, I put this between brackets, saying this is not necessary at all. There's no, you don't get extra credit or anything. It's just for your own sanity to double check that your answer is correct or not. Okay. Now, granted, I must say I did an exercise, another one before, and I wanted to verify my answer, but I plugged it in wrong, and therefore I thought, oh my God, my answer is wrong because it comes out wrong. But actually, the answer was right. So that's a bit of a problem. When the verification comes complicated, you can actually make a mistake there, and that's worse in some sense, because then you think you're wrong and you're actually right, and then you're gonna mess up the things, and yeah, it can be ugly. Anyways, that is your first quiz. The solution for your the quiz also will be posted then the day after your quiz. So don't forget to look at that video, because even if you did everything correct, okay, perhaps that's less interesting than to go, but if you made mistakes or something like that, you want to know what it is. And it's good to, especially in the beginning, make sure that you see the mistakes you make, that you can rectify them, because if you don't rectify the mistakes now, they can accumulate. Very often we're going to do quite similar things. There's always different things, but they're quite similar. So if you have some problem with something, it might be the next quiz, it's the same thing that is going to cause your problems. Okay? So, and especially when you prepare yourself for the final or something, that you should definitely also look at the solution of the quizzes as well as the review of the quizzes. So these videos are there for you to use as much as you can. Right, and I realized that I wanted to say this in the beginning and forgot to say this in the beginning, and now it's kind of a bit pointless, but what I should have said is, I keep that in mind for the next videos, when you do a review of a quiz, don't just passively go through this review, okay? What you should do is, once you see the problem, say, okay, I think I know what to do. I pause the video, solve it for myself, and then you check, once you've done or when you get stuck, you say, okay, let's see what it actually has supposed to be, all right? So use the fact that you can pause these videos at any time to figure out something, or to try to see whether you can now solve it. And as I said, I should have said this in the beginning of the video, but keep this in mind for the following videos. All right.